Alright class, we're near the home stretch of this unit. We are doing double angles today. If you look, these are the three double angle formulas, and actually, if you notice, cosine of 2 theta has three different ones. These are all equivalent. You do not need to do all three. They will all give you the same answer. So just whatever one you feel comfortable using. Alright, so we're going to try doing some of these. So this is very similar to when we were doing the sum and difference ones without an actual angle. We need to draw our triangle based on the information and then use the formula to solve. So this is telling me that I'm in quadrant 4 because I'm between 270 and 360, or 3 pi over 2 and 2 pi. So I draw my triangle down here. I'm going to say this is theta. And then I do sine is negative root 3 over 3. So that's what I get. If I do Pythagorean theorem, I get x squared plus root 3 squared equals 3 squared. X squared equals, this is just 3 and this is 9, so this is 6. So x equals root 6. So I get root 6 for the other side of the triangle. Now I can do sine of 2 theta. Well, if you look up above, well, I guess it's on your sheet. Sine of 2 theta is 2 sine theta cosine theta. So this is equal to 2 sine theta cosine theta. So then the next thing you do is you just plug in what sine and cosine of theta are. They gave you sine of theta in the problem, so you just write root 3 over 3. And now we have cosine of theta, which is root 6 over 3. So then you get a final answer of negative 2 root 18 over 9. You can also simplify that if you have to do that, which would just be 3 root 2, so 3. So it'd be negative 2 root 2 over 3, I believe. When you take the 3 out, you're left with the 2, and the 3's will cancel. So this is the equivalent. So if you simplify, you should get that. Alright, this one we're going to do. It says sine is less than 0. Again, that means the y is less than 0, so we're going to be in quadrant 3 or 4. And then it says the secant, though, which goes with cosine, is 2, which is positive. So that would be in 1 or 4. So then since we're in 4 again, basically, is what this is telling me. So I draw a triangle. Secant is 2 over 1, which means cosine is 1 over 2. So if I draw my theta, I have cosine of 1 over 2. If you do Pythagorean theorem, you get that this is negative root 3. Well, it's root 3, but then you put the negative on it because you're in quadrant 4. And now we have to do tangent of 2 theta. So that would be the formula of 2 tan theta, tangent theta over 1 minus tangent squared theta. Okay, so I write that down again. And now I put my value in. So I get 2 times the tangent would be negative root 3 over 1, or negative root 3, over 1 minus negative root 3 squared. Well, when you square the negative root 3, it becomes just 3. And it gets rid of this negative sign. So don't forget that. So we get negative 2 root 3 on the top. And on the bottom we get 1 minus 3, which is negative 2. The negative 2's cancel, and we get that tangent of 2 theta is equal to root 3. Alright, so that's doing double angle with values. Now we're going to look at just some identities real quick. That'll be on the next slide. So I showed you guys the formulas again, and we go from there. So establish each identity. This is cosecant of 2 theta. I don't have an identity for cosecant, but if I rewrite this, I have an identity for sine of 2 theta. So now I can rewrite sine of 2 theta with the identity. The identity is that sine of 2 theta is 2 sine of theta cosine of theta. So now I can basically rewrite this as, just so you guys can see it better, this is a 1/2, a 1 over sine, and a 1 over cosine of theta, which leads us to the final answer of 1/2 secant theta and a cosecant theta. So that's all we had to do for that one. We just rewrote it by doing our formula. Now this one's a little trickier. So this is equals 1/2 secant theta cosecant theta. There we go. Alright. So this, we don't have a formula for, but this is the flip of tangent of 2 theta. So what I can do is just go right to the formula for tangent of 2 theta and flip it. So I could say that this is 1 minus tangent squared of theta over 2 tangent of theta. Now this requires a little bit of looking at it, because it's a very quick proof if you can see what you need. This is what I did. I looked at the other side, and it says I have a cotangent squared in this spot. So to get a cotangent squared there, I have to multiply by cotangent squared over cotangent squared. And then it should work out for everything. So let's see what happens when you multiply this to both things. Well, you get a cotangent squared theta minus cotangent squared times tangent squared. Those are inverses, not inverses, reciprocals of each other. So we are able to cancel them out and they become 1, which is also what I want on top. So that's good. On the bottom, I have a 2 still. Now here's where you have to think about it a little bit. I have cotangent and cotangent and a tangent. One of these cotangents will wipe out this tangent and become 1, which means we're left with the other cotangent. And that is exactly what I wanted. So that just shows that that is equal to that. That's all I had to do was multiply it by cotangent squared to the top and bottom. Okay, those are the double angle formulas and how you can use them. And we got one more. We got half angles coming up.